This is section 2.1, power and radical functions. Let f be the power function, f of x equals a times x to the n, where n is a positive integer. For example, we could have f of x equals 3x to the fifth power, and nothing trailing it, so nothing like plus 2x minus 7. We're not talking about this situation. We're only talking about when f of x is equal to one term and one term only. If n is even and a is positive, so if f of x were to equal, let's say a is positive, n is even, so 4x to the sixth, let's say. The function will look something like this, but with x to the sixth, it would be a lot flatter at the bottom. It would look something more like that. But regardless, these properties will remain the same. The domain would be negative infinity to infinity. The range is 0 to infinity. X and y intercepts would both be 0. The continuity it would be continuous for all reals. And we would say that the continuity is negative infinity to infinity. In other words, there are no places where this graph would be discontinuous. The symmetry is over the y-axis. The minimum value is 0 at x equals 0. This function is decreasing as you go left to right from negative infinity to 0, and then increasing from 0 to infinity. The end behavior would be as x approaches infinity, y is going to infinity, and as x approaches negative infinity, y is going also to infinity on this side as well. If n is even but a is negative, so we could have f of x is equal to negative 4x to the sixth, then this graph is just turned upside down, and we say it's reflected over the x-axis. The domain, again, is negative infinity to infinity. The range is now negative infinity to 0. All the values will be negative. X and y intercepts are both 0. Continuity, again, is negative infinity to infinity. It's continuous everywhere. Symmetry is, again, the y-axis. The maximum value is now 0, 0. This function is decreasing from 0 to infinity and increasing from negative infinity to 0. And the negative infinity is actually this one. It's the x values. So from negative infinity to 0, this function is increasing. The end behavior is the limit as x approaches positive infinity or negative infinity. Both are going to be negative infinity. If n is odd and a is positive, for example, f of x equals 3x to the fifth, a is positive, n is odd, then it's going to look like a lot like x to the third. So domain and range, negative infinity to infinity. X and y intercept is 0. Continuity, negative infinity to infinity. Symmetry in this case is the origin. That means it is an odd function. Extrema is none. There is no lowest value and there is no highest value. There's no extrema for this one. The function is increasing on negative infinity to infinity. As we go left to right, the function increases the entire time. This function does not decrease. The end behavior is the limit as x approaches positive infinity is infinity, and the limit as x approaches negative infinity is negative infinity. Now, if you make the function negative, all of this is turned upside down. So if we have f of x equals negative 3x to the fifth, the function is now turned upside down from this one over here on the left. The domain and range is negative infinity to infinity. X and y intercepts are 0. This is continuous for all reals. I don't know why over here they go from negative infinity to infinity, and here they do it with set notation, but I prefer this notation right here. Symmetry is the origin, which means it is an odd function. Extrema is none, decreasing the entire time, and the limit as x approaches infinity is negative infinity. Limit as x approaches negative infinity is positive infinity. Graph and analyze each function. Well, we have the graph of the function over here. The domain is negative infinity to infinity. The range is also negative infinity to infinity. With these polynomials, there are no places where it's discontinuous. The x-intercept is 0, the y-intercept is 0. It's this point right here. The end behavior is the limit as x approaches positive or negative infinity of f of x is equal to positive infinity. So if you go to the right or the left, the y's are shooting off to positive infinity. The continuity is negative infinity to infinity. There's no places where this function is discontinuous. Increasing from 0 to infinity, that's from here shooting off to the right, this function increases. And then decreasing from negative infinity to 0, which means it's this negative infinity over here on the x-axis. So as x goes from negative infinity to 0, this function is actually decreasing. Graph and analyze each function. So we take our graphing calculator, we graph it. We have negative x to the 7th. The domain, all reals, negative infinity to infinity. Range is the same. There's no places where we can't count an x value and we can't count a y value. X-intercept is 0, the y-intercept is 0. So this function goes through the origin. The end behavior, the limit as x approaches positive infinity of f of x is equal to negative infinity. And the limit as x approaches negative infinity of f of x is positive infinity. This function is continuous everywhere. It has no asymptotes, no holes, no jump discontinuity. So negative infinity to infinity. This function is never increasing, so we say none. And the function is decreasing the entire time. Graph and analyze each function. We have 3x to the negative 2, which is the same as 3 over x squared. It's interesting to note that we cannot plug 0 into this function. We cannot allow the denominator to be 0. The domain in this case is negative infinity to 0, and then union with 0 to infinity. So all values except 0. The range is 0 to infinity. And we see we have a horizontal asymptote, because this graph is going to level out as it goes to negative infinity, and it levels out to 0 as it goes to positive infinity. The x-intercepts, we have none. This graph does not cross the x-axis. It gets closer and closer, but it'll never touch the x-axis. The y-intercept is also none. It will get closer and closer to the y-axis on both sides, but it will never touch. The end behavior, the limit as x approaches positive or negative infinity of f of x, is both 0 in this case. Imagine if x was really, really large as x approaches positive infinity. We would have 3 over, let's say, 1 million. And 3 1/millionths, if you cut a pie into 1,000,000 pieces and you give someone 3 of those pieces, it's pretty much nothing. Continuity, we have negative infinity to 0, union with 0 to infinity. So we have an infinite discontinuity where x is 0. Increasing is from negative infinity to 0. So this function increases slightly until we get to about 1, and then it shoots up very quickly. So this function is increasing from an x value of negative infinity to an x value of 0. And then decreasing from 0 to infinity. So once we hit 0, we can't include 0. There's a discontinuity there. But from 0 to infinity, this function is decreasing down to 0. Graph and analyze each function. Graph and analyze each function. Now we have negative 3/4, but the x to the 5th, I should write it like this, negative 3 over 4x to the 5th. So again, the function, we cannot plug 0 into x. The domain is anything you want except for 0. You cannot have a denominator equal to 0. The range is negative infinity to 0, union with 0 to infinity. This function starts down here at negative infinity, and then it will level out to 0. So we have all the values for the range up to 0, and then after 0, we'll have all of the values. So we just have to skip 0. X-intercept is none, y-intercept is also none. In behavior, the limit as x approaches plus or minus infinity, as x goes to the right or as x goes to the left, this function is leveling off to 0. So we have f of x is equal to 0. Continuity, negative infinity to 0, union with 0 to infinity. The only discontinuity we have is another infinite discontinuity at 0. Increasing from negative infinity to 0, and also from 0 to infinity. As you start way over to the left with the x values, this function is starting above 0, and it slowly increases till it hits about 1, and then it increases very quickly. Well, then when you jump over 0 and start at 0, it's down at negative infinity, but then as you go from left to right again, this function is increasing very quickly, and then increases rather slowly to 0. But regardless, this function is increasing the entire time, except where it doesn't exist, and it doesn't exist at 0. Decreasing, none. How about x to the 5 halves? X to the 5 halves looks like this. The function starts at 0, 0, and then it shoots up very quickly. The domain is, we can plug 0 into this one because x is not in the denominator. So 0 to infinity. The range is also 0 to infinity. The x-intercept is 0, the y-intercept is 0. And then we have the limit, the end behavior. The limit as x approaches positive infinity of f of x is equal to infinity. And we can't do limit as x approaches negative infinity because the function, the x values just don't exist for negative values. The reason that we can't plug in negative values is this is really the square root of x to the 5th. Now if you plug a negative, let's say a negative 1 in here, we would have negative 1 to the 5th, and negative 1 to the 5th is negative 1, and then we'd have the square root of negative 1, which is not real, it's imaginary. We cannot plug in any negative values. That's why we can't examine the limit as x approaches negative infinity. Continuity, it is continuous on all places where it's defined. So the continuity exists on 0 to infinity. Where this function exists, it is completely continuous. Increasing from 0 to infinity, and this never decreases, none. It doesn't decrease on where it exists. Let f be the radical function f of x equals the nth root of x, where n is a positive integer. If we have the nth root and n is even, for example, f of x is equal to, let's say, the 4th root of x, it's going to look a lot like this function right here. Domain is 0 to infinity, x and y-intercepts are zeros, it's continuous where it's defined, we don't have any symmetry, and this is increasing from 0 to infinity, and we do have an absolute minimum at 0, 0. The end behavior, we can only talk about this going to positive infinity because the function doesn't exist where x is negative. If n is odd, now we can take the 3rd root, let's say f of x equals the 3rd root of x. We can take the 3rd root of negative values. We can't take the 4th root of negative values. That's why the function does not exist where x is negative. Domain and range, all reals. X and y-intercept is 0. Continuous where it's defined. It is symmetric about the origin, which means this is an odd function. And the graph increases the entire time. And there's no place where this graph decreases as you go from left to right. The function is increasing the entire time. Extrema is none. This does increase forever, and it does, as you go to the left, this function decreases forever. So there's not a highest or a lowest point anywhere on this function. In behavior, limit as x approaches positive infinity, the y values shoot to positive infinity, and as you go to the left, or as the limit approaches negative infinity, the y values are going down forever to negative infinity. Graph and analyze each function. So we've graphed this on the graphing calculator. We have an even root, so the domain is 0 to infinity. The range is also 0 to infinity. The x-intercept is 0 and the y-intercept is 0. And we have the end behavior to the right side only on this one. So limit as x approaches infinity of f of x equals positive infinity. The continuity is everywhere this function exists. This function is increasing on 0 to infinity and it is decreasing nowhere. Graph and analyze this function. This function has an odd root. The domain is negative infinity to infinity. The range is negative infinity to infinity. X-intercepts at, well, this is interesting because now we have to find the x-intercepts. So to find an x-intercept, we plug 0 in for y. So we plug 0 in for f of x, which is 1/2 fifth root of 3x minus 4. In order for this side to be 0, 3x minus 4 has to be 0. So we have 3x equals 4, divide by 3, and we have 4/3. So the x-intercept is 4/3, or 1 1/3. That looks about right. And to find out where a function crosses the y-axis, we plug 0 in for x. So if we plug 0 in for x, we have 1/2. The fifth root of, plug 0 in, we have negative 4. And we could use our calculator to get that value, but we'll just call it 1/2 fifth root of negative 4. The end behavior, limit as x approaches positive infinity, is infinity. And the limit as x approaches negative infinity of f of x is negative infinity. As we go to the right, this function is increasing to infinity, and as we go to the left, this function is decreasing to negative infinity. The continuity is everywhere this exists. There's no discontinuity for this function, and this function increases the entire time, so negative infinity to infinity. As you go left to right, this function increases the entire time. So there's no place where this function decreases.